had another question about how to do a second degree polynomial trend line, which is great to tell people you know how to do once you know how to do it. Do you know how to do a second degree polynomial trend line? So it's in question 4, part B. And this is where you've plotted 3 points and you want to create this. It's supposed to be a long run average total cost curve. And I tell you to do this second degree polynomial trend line. And the reason I say that is because I'm hoping most of the cost curves that I've looked at, most of the long run average total cost curve that I've looked at in the past is something like that. So kind of this U-shaped thing. When I say a second degree polynomial, earlier in the class I may have referred to linear functions, which is just a straight line, versus quadratic functions, which are U-shaped, either U-shaped or hill-shaped, and then cubic functions, which have like S shapes to them. And this long-run average total cost curve, I guess I called it long-run ATC. They just call this LAC. The long-run average cost curve has this U shape to it. My guess is that the formula that generates this is going to be some equation that has a Q and a Q squared term in it. If it was just an equation with just a Q term, it would just be a straight line. But since it's U-shaped, then I assume this is going to be a formula that has average cost as a function of Q and Q squared. So the way that Excel uses that is it calls it instead of calling it a quadratic function or a function with a squared term in it, they call it a second degree polynomial. The second degree means that you've got a term that's going to the second power. So just as an example, we've got our Chapter 8 practice problems, and I've already got the graphs here, but I'll just pretend that they're not there. And I've got my, let's see, I don't want to do total product because that's kind of S-shaped. So that would be a third degree polynomial, so I won't do that right now. But I've got the marginal product here, which is kind of funky looking, but it has a bit of a U shape to it. So I'm just going to do a scatter plot of just those. I'm not going to connect the lines right now. And I think in here, in your assignment, I just told you just to make the dots. So if you're going to do this, if you're going to do that question and you choose to graph it, and you do one of the choices where it doesn't show the lines, or it doesn't show the dots, it's going to have some problems later on, because when you do the long run average total cost curve where there's only 3 dots, and they're kind of in weird places because they're not in adjacent rows, then it's going to get a little confused. So as long as you do it where you're kind of showing where the dots are, and right now I don't really want to, I just want to have the dots themselves if I'm trying to plot this trend line on top of it. So instead of just drawing the lines directly where there's a line connecting each dot, I'll just have the dots themselves. So I've got these, and it's gonna differ somewhat. I think there is a PDF that is putting trend lines in scatter plots in Excel. So I've got that somewhere in this module 4 for you to find. And I think I created that PDF when I was on a previous version of Excel. You can look through that if you have an older version. If not, if you have the version that I have now, it's a little bit different, but fairly close. So I've got my chart here with just the dots on it, and I want to put the trend line on there. I want to do a second degree polynomial trend line. So it's module 3, the PDF about putting trend lines in. So check module 3 for that. But here's my dots for my marginal product. And again, if I've done something else, if I've made it and then I've kind of clicked someplace else, then it might be kind of tough to find. But if I click on the picture, then these other 2 tabs show up at the top, the design tab and the format tab. And the trend lines are kind of hidden in the design tab. There's a couple ways you can do this. If I just go into my chart and sort of right-click on one of the dots, then I can actually see, if I come down here, there's this add trend line feature. And that will do it. That'll do what I'm going to do in a second. Or again, if you have done something else and you can't remember that, then you can click in the chart and you see this design tab. And from the design tab, there's this add a chart element. And I scroll down and I see that there's a trend line here. Now I don't really want a linear trend line. Again, my thought is that this, well, at least for marginal product, is still U-shaped, or it's hill-shaped, I guess. So I don't think it's a straight line. I don't want to, this is also a straight line. It's not really a moving average. That's kind of weird looking. So I want to go to this more trend line options. And as I do that, you guys are showing up on top of it. Can everyone see the little options that are on the side here? So this little window popped up. But again, if I did it the other way, if I just kind of right-click on a dot and say add a trend line, then that little thing shows up on the side again. It's defaulting to the straight line, which I don't want, but I wanted to do a second degree polynomial. So here's the polynomial. I'll click that little button, and it's defaulting to an order of 2. Actually, if you have a polynomial of order 1, that's just a linear straight line, so it doesn't actually let you go down. You can't go down to only doing 1. Right now, it's giving me this polynomial of order 2. Again, I could do it order 3. It's not going to be a whole lot different, though. But there's my polynomial of order 2. And you can see it kind of does a decent job of connecting all of the dots. We're tracing it out. And I could also say, if I want to see what this equation is, what the equation of this line is, there's this little checkbox down here, display the equation on the chart, so I can see what the equation is. It would be nice if it would say marginal product equals blah, 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 and with L squared plus blah, 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 L, since that was what those are the variables that I'm using. It's not smart enough to do that. It just does things in terms of X's and Y's. So you have to kind of remember that this is a marginal product graph, and the y-axis here is what my actual marginal product is, and the x-axis is what my labor was. So anywhere I see an X here, it should be an L. So I can see the equation. I can also look at what the R squared is to get a sense of how well explained this equation does in explaining the variation in the dots. This is kind of interesting. It looks like it's pretty far off. I mean, this line connects, it kind of goes through some of the dots, maybe 2 of them that I can sort of eyeball, the one at 4 and the one at 7. But all the others are somewhat far away. Sometimes they're pretty far away. But the R squared is still 0.98, which is still pretty good. Again, when I ask you to plot a second degree polynomial trend line, you will have, a column of your data here with the long run average total cost and a couple of different points that are on there. And just to plot it, again, you'll click on, it might be a little hard because your other lines are going to be in there too. So you might have to be pretty careful with how you actually, like what dot you actually click to add that trend line. But once you do it, again, it's just, right-clicking on the dots and hitting Add Trend Line, or going to the Design tab, add a chart element, do the More Trend Line options. And then once you're there, again, you can go to it's going to be this polynomial of order 2. And again, it's helpful to display the equation, display the R squared. If you wanted to see what it's actually doing, you could go ahead and run a regression. And basically, this is marginal product as a function of L and L squared. So you could go in and make an L squared column and then run a regression with marginal product as your dependent and the L and L squared as your independence. And you'd get this result. I mean, your intercept would be 37.071. The different coefficients for the L and the L squared would be here. You'd see the R squared was the same as that. So if you wanted to just verify, you could do that too.